Welcome to this month's Ask an Expert. We'll be talking about using the Nios 5 and the RiscFree IDE and Debugger for Intel FPGAs. Ask an Expert. We do have, I know this has been a popular topic, and so really looking forward to this. So we have a guest from Ashling. His name is Rajesh. He has been with Ashling. He's an engineering manager there with the Bachelor's in Tech and Electronics and over 15 years of experience in real-time embedded systems with an emphasis on embedded development tools and debugging. So we like to welcome him again. He's from Ashling, and then our own Intel, Shreya is the product marketing manager for soft and hard embedded processors, embedded tools, software, and IP for Intel FPGAs, SoC, FPGA devices in the Intel Programmable Solutions Group. She's been with Intel since 2018, and prior to that, managing the FPGA embedded processor portfolio was an SoC FPGA architect. Her current focus is on Intel SoC FPGAs and bringing the new Nios 5 soft processors to market. Okay, so just so everyone is aware of resources that are available, we have lots of documentation on the web, and so here are some areas where to go. So developers, resources, and documentations. We have specific areas to go to depending on what your interests are. And so here, what we've highlighted are the FPGA development tools and Cortex Prime support resources. So given that Nios 5 is a soft processor going into FPGAs, there's expectation there's probably some FPGA programming involved as well. Okay, and then also we have lots of videos on YouTube. So we produce videos, we post them on Intel. We also publish them on YouTube. And so if you're interested in a topic, maybe that topic has already been addressed and talked about on YouTube. So it's easy to do a search on YouTube to see if such a topic exists. We have a handful of we have a handful of videos that talk about the Nios 5 already. So if you're still interested in that, we have highlighted some of those Nios 5 videos there. And okay, so ground rules. So first off, feel free to use the audio to ask questions. If you're not asking a question, you don't have a comment or a question or something like that, please keep yourselves on mute. That way we can minimize any background noise that is coming through. So as far as questions are concerned, so any questions about okay, so there's a typo there. It says time and closure. We're actually talking about Nios 5. Any questions about Nios 5 is fair game. So just go ahead and talk about it. You can go ahead and use the chat window if you like. Use the audio if you want. If it ends up being a fairly detailed question, what we'll probably do is direct you to your local field application engineer to help you troubleshoot more of that problem. But we'll do the best we can. Okay, so those are the ground rules. And again, I'm your moderator. Stephen Elzing is my name. Again, two ways to ask your question. Use the audio if you like. Use the chat window. I will be monitoring the chat window, so feel free to use that if you're comfortable with that method as well. And let's see, will these slides be available to us? So the slides, the recording will be available, but as far as the slides, we generally don't make the slides available, but the recording we do. So with having said that, I'd like to turn the time over to Rajesh for his presentation. Go ahead, Rajesh.
Yeah, thanks, Steve. Thanks, Steve, for intro, and welcome everyone from Ashling's behalf as well. I'm Rajesh from Ashling. Steve, just before we get started, I don't see the share option from my side, so that when we start the live demo, can you add me the presenter so I can share the screen for the demo, not for the slides?
Let's see, not for the slides. Let's see, for the, I'm sure, let's see, you don't have the share option. Let's see, I think it is, whoops. I have, why don't you go ahead and go carry out the presentation? I lost the controls. Okay.
Yeah, I'll just take the slides and we can take a look at this when I start the real demo.
Okay.
Yeah, so yeah, hi everyone. I'm Rajesh from Ashling, and yeah, before we jump into this live demo of Nios 5 debugging using RiscFree tools, I'll just give a brief intro about who Ashling is and what RiscFree tool is. So yeah, Ashling is a company founded in 1982 with headquarters in Limerick, Ireland. It's a part of JKH Holdings Group, and we do have both products and engineering services for embedded system developers. So we have the R&D engineering team based both in Limerick, Ireland, and then in Cochin, India, with sales offices globally there, including the Silicon Valley office. Ashling is also part of RiscFree International and the Open Hardware Group. So yeah, can we move on to the next slide, Steve, please? Yeah, just introduce the management team as well of Ashling. So on the top left, you have Hugh O'Keefe, who is our CEO based in Limerick. And on the top right, we have Nadeem, who is our VP for business development. He's based in Silicon Valley. Bottom left, it's me, Rajesh, and the engineering manager based in Limerick. And on bottom right, you have Dennis Hayes, who is our CFO, is again based in Limerick. And now here we'll switch to just a brief on these products and services which I mentioned earlier. So products include, these are products for the embedded system development, including IDEs, debuggers, compilers, hardware debug and trace props, development kits, etc. So on the right hand side, you could see some of the debug props and other products from Ashling. And engineering service is obviously utilizing the Ashling expertise in development tools and some secure controllers and other embedded systems, hardware and softwares. So that's where we focus. And I think we can switch to the next slide where we'll be. Yeah, this will just putting down the relationship between Intel and Ashling. So we are working as partners, and we recently had a joint white paper released stressing on this RiscFree based Nios 5 processor from Intel and Ashling, working with Intel engineering team, cooperating, and then coming ready with the tools ready for the Nios 5 debugging, including IDEs, compilers, and debuggers, and trace support for the Nios 5 processor, and also for the ARM processors, all the ARM HPS. Yeah, so with this brief intro, I think we can move to the next slide where we mention about this RiscFree tools from Ashling. Can we just switch, Steve? Yeah, this slide. So this is what we will be demonstrating today, the RiscFree IDE from Ashling. So we call the RiscFree IDE for Intel FPGAs. This is developed by Ashling for Intel, and this is a full package including IDEs where we can write and develop the applications. Then we can have the compilers, debuggers, where we can compile the application and then debug the application on the target, and debugging and trace as well. So RiscFree from Cortex 22.2 and onwards is bundled with Cortex. So anyone having a Cortex installation, you can see the RiscFree installed as part of this one. On the right side, you can see a small screenshot of the Cortex installer where actually we have a tick box to select RiscFree IDE for Intel FPGAs. So if this is ticked once the Cortex is installed, we'll find the RiscFree within the Cortex installation, which I will be showing soon in my demo setup. And yeah, so RiscFree, it's a software development and debug. It provides software development and debug support for Nios 5 cores, not just Nios 5 cores, for the ARM HPS as well. So if you have an Intel FPGA which has with an ARM HPS, you could debug the ARM HPS as well using the same tool with the same instance and the same debug probe, which again I'll be demonstrating today, and supports a wide range of Intel FPGA boards, including Agilex, Stratix 10 Area, and the Cyclone 5 boards. And RiscFree IDE, it has a full support of project management, including build using both Make and CMake based. And also it works closely with the Cortex tools, which means any application or BSP built using the Cortex tools, they could be built and debugged using RiscFree. All of this will be demonstrated. I just want to give a quick overview of what RiscFree IDE tools is, as I said earlier. Yes, if we can move to the next slide. Yeah, just continuing with the features. So the debug probe, RiscFree IDE support the Intel USB Blaster 2 debug probe. So there is no need to go for any third-party tools. We can use the USB Blaster 2 JTAG probe itself for debugging both the Nios 5 core and the ARM cores. Sorry. And we have the visualizations. Just give me a second. The register views, the peripheral register visualizations for both Nios 5 and the ARM cores. And one of the key or the unique features for the RiscFree IDE is the heterogeneous simultaneous debugging, which means using the single instance of RiscFree and one debug probe, we could simultaneously debug both the Nios 5 core and the ARM HPS at the same time. That is again one feature which I'll be demonstrating shortly. And other features include the RTOS aware support for Sapphire FreeRTOS, micro C, all debug aware support, and Linux kernel and application debug support, and real-time trace on chip and off chip. So these are the few key features of the RiscFree IDE. And in the next slide, I'll be just covering up what we'll be touching up on the live demo today. Yeah, we can just have the next slide, Steve, thanks. So this is a setup I have in my machine. It's an Agilex FPGA board connected to the USB blaster, via which we'll be doing the debugging. So USB blaster is connected to my machine, and then using RiscFree, we'll be actually covering 3 steps. One is importing, building, and debugging a bare metal Nios 5 program, and then we'll do the second phase. What we'll be doing is importing, building, and debugging Nios 5 BSP and application, which is built using Cortex tools. And at the end, we'll also see this heterogeneous multi-core debugging. So this is what we will be covering today, and I think I can switch to live demo now. Is that fine, Steve? And I can see the share option right now.
Yes, perfect. Okay, good.
Okay, so guys, just give me a second. Let me share my screen. Okay, I hope everyone should be able to see the screen now, where I have a couple of folders and a shell open. So here, so I'll start from here. So on the right folder, what you're seeing is the Cortex installation, latest 22.2 engineering drop installation. So anyone having the Cortex Pro or the Cortex tools installed, you'll see this folder is free within that one. So that is why I just had the folder open here so that you can understand where this RiscFree is and where we can invoke this one. So within this RiscFree, yeah, we have all the files and folders required to invoke the RiscFree IDE. So you can see a RiscFree folder here, within which I can just go double click this RiscFree.exe, and then I can have the RiscFree ID invoked. But I recommend a better way of doing it is that rather than invoking from there, we have a Nios 5 folder here, within which we have a Nios 5 shell. If I double click, I can open this Nios 5 shell, and within this Nios 5 shell, I can also invoke RiscFree. So the advantage of invoking RiscFree from this particular shell is that it will also add the path for these folders, and we could access other utilities, the Cortex utilities also within RiscFree. So that is the reason I'm invoking from here. So I just switch to this RiscFree folder. I'm just clicking RiscFree exe here. At this point, you can see the RiscFree being invoked. So first step, as with any other Eclipse-based IDEs, is to choose a workspace. So I'm just giving a name. It should be, there is no condition, precondition. The only condition that this folder should be a folder with the right permission. So right now, I'm just given a folder, a workspace underscore Agilex is my the folder name I'm giving, and then I'm launching this one. And now we should be seeing the RiscFree being invoked. Yeah, so now we can see a clean slate, like nothing here. It's a new workspace, and we can create new project, import new projects, also all those things. So as I was telling earlier during the presentation, first step is we will build a bare metal application for Nios 5 and debug this application. So within RiscFree, we are also bundling a few sample projects. So we have the sample projects for Nios 5 and also for Agilex. So I'll just import those projects, and then we'll build it and debug those applications. So I have the option import projects here, and within import here I have the CPP sample projects which are bundled. On the next page, you can see all samples which are bundled, and within which right now we are working with an Agilex board. So within Agilex, I have 2 samples. So one is for the Nios 5 soft core, and one is for the ARM HPS. I'm just importing both for the moment because Cortex a 53 sample, we'll be anyway using it later. So I'm importing both the samples. So in the Project Explorer, right now I can see both the projects. So we'll start with Nios 5. Building is as simple as just right click. We have the build option. So we can see the build right now happening. So as I was telling earlier, this RiscFree is bundled with the Nios 5 GNU GCC toolchain as well. So right now we are using the toolchain and we are building the application. If you right click any project, we have the other settings here. Within the settings, we have all the toolchain settings. So by default, we have some sensible defaults, but all of these, the compiler settings, compiler flags, linker flags, everything can be overridden from the properties page, as I just now took the compiler options, the linker options, the linker file, all these options can be changed here. Okay, so coming back, we just build the application right now. So if I expand the project, you can see a new ELF file being created here. So next up, we want to download this ELF to the soft core and then start debugging. For this one, I right-click the ELF file. I have the debug as debug configurations options. I just click the debug configurations options. You will see a number of launches here, which I'll be covering later when I go to heterogeneous debug and all. At the moment, let us focus on this RiscFree auto detect hardware debugging launch, which is a launch we should be using for the Nios 5 course. So I have created a new launch here, and you can see the project has been auto-picked. The ELF file has been auto-picked since I was right-clicking the project. So nothing to do here. We can just leave everything as default. And we have a startup tab. Again, we can leave everything default. What we are specifying here is that, okay, I need to load the image to the target. I load the symbols. I'm putting a breakpoint at main. I'm choosing the resume option. So which means I download the program, I run the program up to main, and then I take up debugging. And debugger tab, this is the important tab where we have all kind of configurations. It's a three-step process in debugger tab. One, we choose the probe, the debug probe for the current debug session. It is all available probes will be listed here in the dropdown. So right now I have only one debug probe in my machine, so that is already auto-picked. If we have multiple debug probes, all the debug probes will be listed here, and we can choose the one for the current debug session. So no change required here. I have the USB blaster selected here. Transport type is going to be JTAG. So we have again set there. I have a sensible JTAG frequency as well. I'm not moving it, sticking around with 16 megahertz. So the probe configuration is done. Second part is the target configuration. So we need to choose the device and the core for debug session. Again, the user, he need not know anything about the scan gene details, because we have a feature called auto detect scan gene. So when we press this auto detect scan gene, you can see all the devices in the scan gene has been listed here. So this has this Agilex HPS, which is a ARM HPS core. And then we have the second one is the FPGA, in which we have the Nios 5 soft core running. So all will be listed here. We just need to choose a device for a debug session. I'm choosing the FPGA, and on core selection again, it will be filtering out all the other cores other than Nios 5 core. So right now we have only one Nios 5 core in the image I am working with. So the Nios 5 core is again auto selected. If you have multiple Nios 5 cores, again the dropdown will be showing all the Nios 5 cores, and we can choose the core which we need to debug. So that part is also now done. We have selected the debug probe, we have selected the device, and we have chosen the core as well. All other settings, we can just leave it as default, and I'm applying, and I'm pressing debug. So at this point, what we expect to happen, the program, a connection should be established, and this ELF file which we built right now is now downloaded to the target, and a run to main should happen. So you can see here, so now the program debugging has started, and we have run to main, and like all the runtime operations you can do. I can do a single step here. We can watch the variables. We have a debug view here showing the call stack. So right now we are in main. So maybe if I step into this function, you can see the call stack showing here main. From that we call sum. So from this point, it's a very simple application. It's just a sum program which does a sum of two variables, and just to demonstrate. And here, all the runtime operations step into, and we can step out. So we can step out from this function. We go back for it is called. We can put some breakpoints, just run, hit the breakpoint, all kinds of debug operations. We have registers view where all the GPRS registers, CSR registers, all of this can be viewed here. So in CSR, in fact, we have the description as well. Like it is not just the register values, the interpretation as well. So you can see here, this is an RV32 core we are working with. So those kind of informations, when ready, architecture ready, all the CSR registers, all informations are available. And yeah, memory views. So maybe I can open, all the views can be here, window show view. I'll just open the memory view as well. I'll just monitor a location near to the text area. So here you can see all the memory values. So all kind of runtime debugging can be now done for this Nios core running this application. And yeah, the views, register view, breakpoints, just putting a breakpoint here, breakpoint views, register views, memory views, all basic debug requirements are covered here. So this was actually the phase one of the live demo I was mentioning earlier when going through the slides. So what we did right now is import a bare metal sample, which is bundled with RiscFree into our project. We build it and we debug the application. Now phase two, what I'm going to do, instead of using this application, which is already bundled with RiscFree, what I'm going to do is we have the tools coming with quotas using which we can create BSPs and applications for the Nios course. And what I'm going to do is that we are going to debug such an application which is created using these Kotas tools. Okay, so I'm just going to terminate the session. This one just stopped debugging, just remove everything. Okay, so I'll go back to my folders, open there. Yeah, I was talking about different tools bundled with quotas, which we can use for this BSP creation and application creator. So these are here, like within the Nios folder, bin folder, we have this Nios app, Nios BSP, which is used for generating the BSP for my image, and the Nios app for generating the application for my image. And I would like sorry, just give me a second. Yeah, I would like to just introduce another feature for RiscFree, where this is called the external tools configurations. So using this feature, we could invoke any external tools within RiscFree. So I'm just leveraging on this feature to run these external tools like the Nios app. You can see I'm referring to the Nios app here and the Nios BSP. I have the Nios BSP here, and even other tools within Quarters like JUART terminal, which is a utility for seeing the UART output from the board. So right now, what I'm going to do that, I just bring up that folder again. Yeah, I have this folder. Yeah, BSP is already generated. So this folder is generated using the Nios BSP folder. Nios HAL, the app is still not created. I just have my hello.c file here. So here, if I go to Nios app, you can see my parameters here. I'm choosing the Nios app, and then yeah, I'm passing all the parameters, what BSP I should be using, what are the source files I should be using. So I give all this, when I give the run command, you can see the make file will be created here. So you can see here the make file has been created for this app. So what we are going to do right now is that we are going to create, this is a CMake based project. So we are going to import or maybe open this project within RiscFree and build the project from RiscFree and then debug the application. So this is an app, this is going to be an application which is going to use the Nios HAL as well. Okay, so for that, we go back to Project Explorer. Yeah, we just choose the option file, new project, and this is a C++ project. So I go for C++ managed project, and we need to browse to location where we just created the app folder, CPU app folder. This is a folder I just now created. I'm choosing that one, and I'm giving a name for my project. So I'm just choosing the same folder name, CPU app. And what is important here, this is a CMake driven project. So I click the CMake driven project, empty project option here, next and finish. That's it. So we have this new project created here, CPU app, and just right click, we can build it, and we can see the build happening over here. So the CMake configurations, everything happening. If you go to app folder also, we can see the new files all created within the build debug. We can also see the ELF being generated. So all the BSPs are being referred to, all the obj files. And then, yeah, that's it. The ELF file has been created. So here right now, we can see the CPU HAL ELF. So what we did right now, we created a CPU HAL app and BSP using the Cortex tools, and then we opened that in RiscFree and build the application. And now we can debug the application. Is again pretty much going to be the same set of steps what we're doing for the other application. Right click the L file, debug as, debug configurations. I'm just going to create a new configuration. So we can, yeah, CPU HAL is a name, is taking the name of the L file. Again, the project name, the ELF, everything has been selected. The startup tab, everything I'm leaving it as default, load image, all those details. Debugger tab. So all sensible values, we'll do the same step what we did earlier, auto detect. We go with the softcore, the FPGA, the softcore Nios 5 has been selected, apply and debug. So right now we should see again the program being downloaded and we run to main of this HAL based application, which we built right now. So here you can see we have run to main, and what this application done, actually it is using the HAL. So you can see it when we use this printf here, with the help of HAL, it is actually printing this to the UART. So to see the UART, again, I'm using this facility here, external tools configuration, and I have a setting here. I have a launch here for JUART terminal. This is again, as I said earlier, it's a utility to see the UART output. So I'm just running the JUART as well here. Just run here. It's a new launch, so you can see the any UART output we should be able to see here. So what I'm going to do, maybe I'll put a breakpoint here. I'll just run this one, and this should call this looper function in which we are printing this one 1,000 times. So I'm just running this one, so you can see all this UART print coming over here from 0 all the way to 999. You can see here. So again, this is just showing that all these utilities within Cortex, we can have it open from within RiscFree environment itself. We need not have different shells, so consoles open. Everything can be done from within RiscFree. So I'm not going to other debugging because everything debugging features all still they remain the same. Just want to show this capability of building the HAL application from within RiscFree. And the difference, the first one was a make based and this is a CMake based. So covering those two as well. And so this was the second phase I was discussing what we will be covering in the live demo. And the third phase is the heterogeneous debugging, which means I'll be simultaneously debugging RISC-V and ARM. So maybe I can just leave this launch as well. Right now we are debugging the Nios 5 softcore and we have hit a breakpoint. I can leave it as it is. I can go back to my launch. I can start a new launch for ARM and I can debug ARM as well at the same time. So for that, earlier we imported the ARM sample as well. And here I have the ELF for that. Right click again, all pretty much same debug configurations. So we were using the RiscFree launch so far because we were debugging the RiscFree based Nios 5 core. And now we are going to debug an ARM launch. So I have a launch already here for that. I'm choosing ARM. Same settings, the project has been selected, ELF has been selected, startup tab, we leave it as it is, load image, run to main. Within debugger tab here, again, all sensible values. Let me pick the same data frequency for ARM as well, since we are working with 16 megahertz for the other core. So here, a device selection, we have a drop down. So I'm working with Agilex. I'm choosing Agilex tab selection. Everything is done. Core selection is Cortex A53. It has actually 4 Cortex A53 cores. I'm choosing the first one, leaving everything else as default. And now I'm pressing debug, and we should be seeing a new launch here. So you can see the launch is happening. So we are downloading this ARM program, the ELF to the ARM core. So you can see that also has happened right now. So if so on the left, we can see the ARM call stack. We can see the RISC-V call stack as well. And based on our debug selection, the debug context selection, whenever I'm clicking on the Nios 5 call stack, I can see the debug, the context for the Nios 5 core. Maybe I'll bring up something else, disassembly. I'll just enabling disassembly view. So now I'm clicking on the Nios 5 context, I can see the Nios 5 disassembly here. And if I'm clicking on the ARM, we can see the ARM disassembly here. And like you can see the switching from 32-bit to 64-bit as well. So these are all ARM instructions. And clicking on RiscFree will bring up the RiscFree instructions. So all the entire context, not just disassembly view. If I have the register view open again, here we are seeing the Nios 5 registers, but I click on here, I can see the ARM registers. And there are even advanced features like we can actually clone register views or any debug views. Okay, so this is the open new view. I can just create a copy of this register view, and now I can actually check or see in tandem, in parallel, the Nios 5 and the ARM registers. So I have two copy. I'm selecting the ARM, the Nios 5 one. I have the option pin option here. So once I do the pin option, you can see the pin being shown here, the red, green pin shown here. So this view is now always going to show the Nios 5 registers, and I'm going to pin the other register view against the ARM. So on the right, we're always seeing the ARM register views. And now we can do all kind of debugging. Maybe I can put a breakpoint over here. I just run the ARM. I can see the ARM registers being updated. Nios 5 is still there, and Nios 5 actually this program exit now. Maybe I'll put a breakpoint. You can run here. You can see the Nios 5 registers getting updated. So like this, we can compare the registers, and again stressing it is not just registers. Any debug view, we can use this feature pin and clone, and then we can compare the values. So that's the simultaneous debug. Right now, what I did is actually two different launches, one for ARM and one for Nios 5. In fact, we have other launches, another launch called the Heterogeneous multi-core debugging launch, which I'm not going in detail. It's a single launch from which we can select both the ARM core and Nios 5 core and do the debugging. So once we do that, the debugging is again going to look the same, but the advantage is that we don't have to have two different launches. So this is the third part, like the heterogeneous simultaneous multi-core debugging with both the Nios 5 soft core and the ARM HPS. So I think pretty much I have covered everything, Steve, what I want to cover in the live demo, covering both the CMake based build, Make based build, and the ARM debug and the Nios 5 debug. I'm not sure if
Great.
I'm run out of time.
No. You're good. This is excellent. What I'd like to do is there were a number of questions and answers that came through the chat window. I was going to go ahead and voice those, so we have those on the recording. So if we just hang tight for just a minute here. Okay, so one question that came in has been answered. Is this RiscFree IDE available in the Quartus Lite edition? The answer was Nios 5 will be part of the Quartus Standard and Quartus Lite early next year. The IDE will be available at that time. Let's see. I'm going to read the questions and answers that have already been done, and then I'll go back to the questions that have not been answered yet. Let's see. Okay, so what version of Quartus will this first be available in? It's available now, starting with the 22.2 Pro. Then asking about Cyclone 5 SoC not supported. So the HPS for it is supported at this point, but Nios 5 will be supported later this year when it's available for Quartus Standard. Let's see. And then can Quartus Signal Tap be used simultaneously to using RiscFree IDE to debug ARM or RISC-V processor code? And that feature will be available in a future release. Let's see. Okay, so those were the questions and answers that I was able to scan through the chat. Then the questions that are unanswered at this point. Give me a moment here. Okay, command line interface supported. So is command line interface supported? This person uses Bash script for the build script.
Yeah, the answer to that is yes. So this RiscFree tool, it has a command line interface as well. So on the backend, we have a GDB server, which can be invoked from any bash script. And then all these runtime operations, everything can be done from command line as well.
Okay, great. Thank you, Rajesh. Another question came in. Are hardware breakpoints available when using the USB Blaster 2 as the probe?
Yeah, again, the answer is yes. The hardware breakpoints are supported via the USB Blaster, as long as the hardware breakpoint resources are available in the soft core and the ARM HPS.
Okay, thank you. Okay, Okay, is there any of the OS bundled with the tool, such you can specify it and the tool download the OS from a Git repository, include it in the project and build it?
From a RiscFree perspective, yeah, no OS itself is bundled. Only some sample bare metal applications are bundled, but not sure if we can answer from a Quartus perspective if any RTOS is bundled or not.
Yeah, so
The
from Quartus, we do have the microC OS 2 currently, which is bundled. And in the future, we are still evaluating if we're going to bundle additional ones or there's going to be a different mechanism, either through Git, but we haven't locked that down yet.
Okay, thank you. Another question that came in, will Intel continue to support Nios 2 and Avalon?
So we are going to continue to support Avalon. And for Nios 2, at some point in the future, we are looking at not supporting it. But again, we're not certain exactly when, but we're evaluating. We're looking into that right now.
Okay. Another question that came in and was answered. So is the ARIA 10 HPS supported in RiscFree? Oh, sorry, no, that one has been answered. A question came in. So is the ARIA 10 HPS supported in RiscFree IDE?
Yeah, the answer is yes for that.
Okay.
So we could debug the ARM HPS within ARIA 10 using RiscFree.
Let's see, and then a follow-up to the question: can quarter signal tap be used simultaneously when debugging the Nios? Answer in the chat window says yes. All JTAG tools should work simultaneously with RiscFree. It'd be a matter of coordinating your signal tap and what you've tapped into in your Nios processor there. Okay, so I think that wraps up the questions that are currently on chat. There were some questions that came in during registration, so I'm going to go ahead and ask some of those. But the audience, if you still have questions, feel free to put them in on the chat window. Another question that came in during registration: is a paid license required to use the RiscFree IDE?
No, it's free, and there's no license required.
Okay. All right. So another question then: who provides support for the RiscFree IDE?
Intel provides support.
Okay. So then I just to follow up with that, I guess if there's any problem, since Intel is one delivering RiscFree, they should not be contacting Ashling about questions or anything like that. Is that correct?
Yes, you can directly contact us, and then we work with Ashling should we need to.
Okay. Let's see. Will the IDE support Cyclone 5? Let's see, actually, that question has been answered. Just to finish off the question, will the IDE support Cyclone 5 and other devices according to standard? So yeah, that was a popular question that came up in the chat windows there. Let's see. Oh, okay, so here's a good question. Is Nios 2 supported by RiscFree IDE?
No, Nios 2 will not be supported.
Okay. Okay, so this question is a matter of migrating designs, your software designs from Nios 2 to Nios 5. Let's see. So the question is specifically, how can I port my Nios 2 application to Nios 5?
So Nios 5 supports all of the hardware, bare metal hardware abstraction layer, just like the Nios 2 and similar RTOSes. And so our intention was to make migration or porting easier from Nios 2 to Nios 5. So that's why we continue that on Nios 5.
Okay. Another question: can I debug multiple Nios 5 cores?
Yeah, again, answer is
Yes.
yes for that. Yeah.
Okay. All right. Here's another question. What are the differences between Nios 5 and Nios 2? As a question came up during registration.
Okay, so from the software perspective, Nios 5 does not require Windows subsystem for Linux and uses CMake. This is something that Nios 2 did not use. for building applications. And then in terms of, I mentioned earlier, terms of the hardware, same hardware abstraction layer and RTOSes are supported. So there are similarities in that regard. Also, Nios 5 is superior in performance and features compared to Nios 2. For Nios 2, it was only supported by the Nios 2 EDS. However, Nios 5, you have the option, given that it's a RiscV architecture and given that RiscV has a growing ecosystem, you can use any other tools and tool chains and IDEs of your choice that would work with any RiscV processor, would also work with Nios 5. And then one of the other things is, in the Nios 2 family, we only had 32-bit cores, but we have plans for 64-bit cores for Nios 5. And also Nios 5 cores are free of cost. Some of the differences.
Okay, thank you. Thank you for that. Then there's actually a good follow-up question in the pre-registration questions. What is the performance of RiscV compared to Nios 2?
Sorry, can you say that again?
Yes. What is the performance of RiscV compared to Nios 2?
Oh, okay. So the performance is about 2.5, no, I think 4x compared to Nios 2E. So the Nios 5M core that is available now, that is our Nios 2E replacement. And so performance on that is measured on Agilex as an example, is about 4 times that of Nios 2E.
Okay. Okay, thank you. And then a question that came in on the chat window. What are the differences between ARMDS and RiscFree IDE?
Yeah, the ARMDS. Okay, yeah, Shrey,
Go ahead. No, go ahead, Rajesh.
Okay, yeah, the ARMDS is of course from ARM and RiscFree is from Ashling. So, and yeah, key difference maybe ARMDS. I think it's for debugging only the ARM cores, whereas using RiscFree, you could debug both RiscV cores and as well as the ARM cores. And in addition, yeah, you have the build tools. You can build the RiscV. When I say RiscV, I mean Nios 5 here. The full tool chain to build the RiscV cores as well.
Okay, thank you. All right. Let's see. Okay, so here's a question. So third-party IP promotion distribution policy by Intel. So if I were to read between the lines with that, maybe we have a customer that is building peripherals that make it easy to attach to the Nios 5. Maybe we could comment a little bit about third-party IP promotion distribution policy.
I'm not sure.
Yeah, and I'm just going to guess here. We do have third-party IP that's generally available as far as Quartus is concerned, but generally there's not much promotion, maybe in the form of advertising that's there, but then we end up redirecting any customers' inquiries about a particular IP to the vendor itself. So that's probably as far as it goes. And I imagine if there was an embedded IP, it would follow a similar situation. Although again, I'm guessing, but that's just based off of what I've seen with third-party IP for Quartus. Okay, let's see. So another follow-up on the question about hardware breakpoints. There was an individual who added some more clarification to that. So our hardware breakpoints available. Let's see, available when using this, and the answer is yes. With current Nios 5 core exposes one hardware trigger register currently. So one hardware breakpoint can be supported in the current architecture. So there we go. We have one hardware trigger in register currently in the Nios 5 core. Let's see. Oh yes. Okay. So here's a question. Does Intel integrate the Nios 5 and PCIe engine master with the PCIe backplane and with the device driver?
So if that means if we have Nios 5 PC, IE device and root port drivers, then the answer is no. We do not have plans to do that at this point.
Okay. Let's see. So this question has come up a bit. Maybe just a little bit more elaboration on timeframes there. Will Nios 5 be offered in Core to Slide? That seems like a very popular question. So I guess a time scale or a time frame when customers can expect Nios 5 in Core to Slide.
I think we're looking at later this year when the 22.1 standard release comes out.
Okay. Let's see. Okay, then a question came in: Does IDE support? Does this IDE support ARM on the Cyclone 5? And the answer to that is yes. There's Rajesh did a very good job in the demonstration. One of the demonstrations was debugging both the ARM and the Nios 5 inside there. So the answer to that question is yes. Okay, let's see another. Okay, so here's a question about there's a lot of interest in Nios 5 in some of our excuse me, sorry about that. Some of our earlier products can so we've talked about being supported in Cyclone 5, but will it be supported in Cyclone 4?
Right. So Nios 5 is device agnostic, which means that once it's available in standard, you could use it on any device in standard.
So if they wanted to use it in a Max 10 part, they could
Yes.
at that point then. Okay.
Yeah.
Perfect. Let's see. So one of the questions here, get some insight into debug processing system logic for the programmable logic. So maybe a little bit of insight, maybe a little bit of background there. So while the RiscFree IDE is debugging the application running on the processor, what would customers be able to what kind of tools they have available to them to debugging stuff that's running in the programmable logic section of the FPGA?
So if I understand this question correctly, I think they're asking about being able to trigger the HPS through the FPGA or vice versa, and the cross-triggering feature. But that will be available once trace support is available, which will be later this year.
Okay, another question in the chat window: what are the profiling and tracing tools differences between ARMDS and RiscFree?
Yeah, again, so tracing, as Trey was just mentioning, it is coming by end of this year, and then you will have this both all the profiling features. I don't know, I don't have a comparison with ARMDS, but pretty much you should have all the features.
Okay. And I think I've gotten through all of the pre-registration questions. Are there any other questions that the audience has? Okay, another question comes in: will trace support still require just the USB blaster too?
Oh, sorry, I missed it. Yeah, no, for the trace, like we have two trace here, the on-chip trace and the off-chip trace. The on-chip trace where the trace is stored on the on-chip memory. For that, yeah, we can still use the USB Blaster 2, but off-chip trace, it's actually emitting through the pins, and definitely USB Blaster 2 is not enough for that. USB Blaster is a JTAG probe. So for that, you'll have to use the other Ashling. We have a trace probe, which can do this off-chip tracing. So for that case, the Ashling tools have to be used.
Okay. Another question coming in is: system ID check, unlike in Nios 2, not needed for Nios 5? So let's talk about a system ID check. Will a system ID check be needed for Nios 5?
So I can answer that verbally while I'm typing the response in the chat, but the system ID check is not integrated into the RiscFree tools like it was in the Nios 2 development tools. So from that perspective, that capability isn't supported in RiscFree, but the concept of using a system ID in order to keep your system coherent between hardware and software is still a very highly suggested, best known method of implementing a Nios 5 system.
Okay, thanks for following up on that. Let's see, presentation link available. Yeah, so when this is done, when the recording is done, we do send a follow-up email where the presentation link, so we'll have that uploaded, ready to go. What I'm going to do, I do see if there's a question there, but I want to make sure I get this in there before I forget. I'm putting in the chat window the survey link. If you wouldn't mind going in there and filling that out, that'd be great. So there's a survey link, and then the other question that we have in the chat window: do we get Hello World and other templates like we did on Eclipse for Nios 2?
Yeah, pretty much. Like, since we are providing the samples here, so the samples itself are kind of templates where we can just replace the main.c file with the sample, the actual application we want to work with. So those samples are always the reference and getting started points.
Okay. Okay, so if the audience doesn't have any more questions available, I don't have any more questions either from the pre-registrations. I think we can go ahead and finish this. Rajesh, if you wouldn't mind, give me control gives. I'll share my screen so I can finalize the last couple of slides.
Okay, so I do not know. I still had the control.
Oh, there we go.
You can
Okay,
take
so
control. Yeah.
yes, thank you. All right. Let's see, give me just another one here. Thank you, everyone. Okay, so we'd a big thank you to Rajesh for taking time out of his day to do this presentation. It's been very helpful, and the live demo was very nice as well. Here are some links for the for Nios 5 and RiscFree IDE for the Intel FPGAs. We got some resources listed there, and let's see if I can quickly copy and oh nope, we're not gonna be able to. I'll copy and paste these links here in just a moment. Thank you for attending. You'll soon receive an email with links to a survey and recording of this session. And again, thank you for our presenters. And that is it. Thanks, everyone. And I hope to see you next month in our Ask an Expert session.